So in this case on Taylor series, you'll be told use Taylor's theorem to expand sin pi over 4 plus h in ascending parts of h up to the term in h cubed. Are we together? And hence determine the value of cos 60, cos 63 degrees, correct to 5 decimal, correct to 5 decimal places. You are determining cos 63 degrees, yes, but you are not going to evaluate it in degrees. You are going to evaluate it in pi radians. Because we said when you are going to expand this function, it is going to be a product of the derivatives and the h, isn't it? And you know h, if the derivative, if you are going to look for the sign of any function, the answer, the output of the calculator is pi radians, isn't it? So if you leave the h in degrees, it's like you'll be multiplying pi radians times degrees, which is irrelevant. Are you seeing that? Are we together? Yes. So you are evaluating cos 63 degrees, yes, but when you're doing the evaluation, you must convert them into pi radians. Because for instance, if you get cos 60 in the calculator will give you 0.5. This 0.5 is not degrees, it is pi radians. Are you seeing? Meaning the value of h must also be pi radians. Are you getting the point? Is that understood? Good. That is understood. That is okay. So the first thing before we expand sin pi over 4 plus h, we need to know how to expand a function of x plus h in the Taylor series, isn't it? Because when you have sin pi over 4 plus h, meaning this your pi over 4 is x, isn't it? Are we together? So how do we expand f of x plus h in the Taylor series, isn't it? Are we together? Yes, so if you have sin pi over 4 plus h, meaning we are going to expand a function of x plus h, you can only expand two functions, either a function of x or a function of x plus h. Because this is dealing with h, then we are expanding a function of x plus h, isn't it? And when you are expanding a function f of x plus h, meaning you are starting from f of, when it is Taylor series, when you are expanding a function of x, you start from f of 0, isn't it? When it is Maclaurin series, I mean, isn't it? And when it is Taylor series, you are expanding a function of x, you start with f of a, isn't it? But when you are expanding a function of x plus h, you start with f of x. Are we together? We dealt with that in the introductory part, isn't it? So the first one will be f of x, then plus, you leave a space, then we have, you just have f prime of x, then you leave a space, isn't it? You differentiate it for the first time, then plus, you differentiate it for the second time, you leave a space, then plus, you differentiate it for the third time, you leave a space. You are reaching f triple prime because we have been told to reach up to h to power 3. Meaning f triple prime is where we have h to power 3, isn't it? So you start with the function f of x, then you differentiate it for the first time, f prime of x, isn't it? Then you differentiate it for the second time, f double prime of x. Then you differentiate it for the third time. Then you come back. When you have f prime of x, meaning it is over 1 factorial, then your h is raised to power 1, isn't it? Ascending powers of h. Are we together? Is that understood? Yes. When you have f double prime, meaning it is over 2 factorial, then your h is raised to power 2. Is that okay? When it is f triple prime of x, meaning it is over 3 factorial, then your h is raised to power 3. So you reach up to the term in h cubed, isn't it? Then we now start, we now want to substitute everything. You come and start, what is your function f of x plus h? Your function f of x plus h, you've been told it is sine x plus, it is sine pi over 4 plus h. Are you seeing that? Meaning this pi over 4 is the x. Is the x. Are you seeing that? Are we together? Yes. So from here is the sine x plus h. That implies that your x is pi over 4 according to the equation. Is that understood? Is that okay? Yes. So it is from this f of x plus h is where you can now get your f of x. Meaning for you to get f of x from x plus h must be 0, isn't it? Are you seeing that? Yes. Meaning if h is 0, you remain with f of x to be equals to sine when h is 0. So you see f of x is sine x because we need this f of xx. Are you seeing that? Are we together? Is that okay? Good. So from here we start. If we differentiate f of x for the first time, if we differentiate sine x, we have cos x. Good. If we differentiate f prime, we get f double prime, isn't it? We get f double prime of x. So if we differentiate cos x, we have, this is direct. Here you don't look at the unit function is x. If you differentiate unit function, you get 1. So unit function does not affect the outer function, isn't it? Are you seeing that? Good. Then if you differentiate f double prime, you get f triple prime of x, isn't it? Are we together? Negative is outside. If you differentiate sine x, you get cos x times negative, you get negative cos x. See, we've reached f triple prime of x. See, that's where we end. Are we together? Good. Now, you now start. These are now functions of x, meaning we need this, we need this, we need this, we need this, isn't it? Then you go again, what else do we need? We have f of x plus h, isn't it? So here, the first thing now, we now put the value of x. X is pi over 4, isn't it? So where there is x, can you now put your pi over 4 where there is x, isn't it? Are you seeing that? Where there is x, you put pi over 4. Now you are going to have f of pi over 4 plus h. Will be f of pi over 4. Are you seeing what I'm doing? Because x is pi over 4. So where there is x, you put pi over 4. So we have f of pi over 4, isn't it? To be equals to f of pi over 4 plus f prime of pi over 4 over 1 factorial, then h raised to power 1, then plus. Go on. F double prime of pi over 4 over 2 factorial, h squared, then plus f triple prime of pi over 4 over 3 factorial, then h cubed, isn't it? Are we together? Can we now start getting there? Start with the first one. If we have f of x, we can get f of pi over 4. The calculator must be in pi radians. Are you seeing that? Are we together? The calculator must be in pi radians. So start with the first one. What is f of pi over 4? Meaning f of x, where there is x, you put pi over 4. Are you seeing? Where there is x, you put. So you get f of pi over 4 is sine pi over 4, isn't it? It is sine pi over, which you get to be 0.70711, isn't it? Because pi over 4 is 45 degrees, isn't it? Yes, special angle. And special angle, that means it is root 2 over 2. You can see it is 1.4, meaning 0.7. Some of these things you just see. Meaning if you're doing a wrong thing, you just know you're doing a wrong thing. So f prime of pi over 4, what is that? So here we have f prime of x, meaning where there is x, we put pi over 4, isn't it? So f prime of pi over 4, it is the same thing. Because I can see that is the cofunction identity. Complementary angles. Sine is equals to cos when the sum of the angles add up to 90 degrees, isn't it? Are you seeing? Yes. You move to the next one. F double prime of pi over 4. Here we have f double prime of x, isn't it? So f double prime of pi over 4 because our x is pi over 4. Are we together? So f double prime of pi over 4 is negative sine pi over 4. That is negative 0.707. Are you seeing that? Are we together? If you are using that right calculator, you are going to get root 2 over 2. Easier to work with instead of writing all these decimals all the time. Are you seeing that? Then you move to the next one. F triple prime of pi over 4. Where there is x, you put pi over 4, isn't it? So you have negative cos pi over 4, isn't it? Then you get negative 0, 1. Are we together? Yes. So where there is x, if you put pi over 4, now can we now substitute? Start substituting f of pi over 4 plus h. What is f of pi over 4 plus h? Remember, f of x plus h, x is pi over 4, meaning this is f of pi over 4 plus h, isn't it? It's the same as what? sine pi over 4 plus what is there? Are you seeing? Meaning this f of pi over 4 plus h is our function, sine pi over 4 plus h, isn't it? Because it is this, where there is x you put pi over 4, isn't it? So f of pi over 4 plus h is sine pi over 4 plus h, isn't it? The function they want. So you substitute that, it is sine pi over 4 plus h to be equals to what? Now if you look at this, f of pi over 4, f prime of pi over 4, f double prime of pi over 4, f cube prime of pi over 4, you can see this 0.7011 is common for all of them, isn't it? What do? So you factorize out a common factor. See, this says here we have 0.7, the negative or positive side is what will remain inside, isn't it? But you can see this was 0.70711, it is a common factor for all these. Are you seeing? Yes. Because you can see f of pi over 4 is that same number, f prime of that is the same 0.7, this f double prime of pi over 4 is the same 0.8, it is only negative which will go inside, isn't it? Are you seeing? So this 0.70711, it is common for all of them. It is common for all of them. See, we now factorize it outside. Are we together? Yes. Are you seeing that? So we factorize out 0.70711. Then what do we remain with? Here, f of pi over 4. See, we remain with 1. See, if we factorize this outside, we remain with 1 because it is positive. Are you seeing? Studio? Yes. F of pi over 4 is 0.70711, but we factorize outside, meaning we remain with 1 there, isn't it? Then f prime of pi over 4 is what? 0.70711, it is positive, we factorize it outside. So what we remain with h prime over 1 factorial, isn't it? H prime over 1 factorial, see that's just h. Are you seeing what is happening? Yes. Then here, f double prime of pi over 4 is negative, but we factorize this outside, so we remain with the negative 1 inside, isn't it? Yes. Are you seeing that? Yes. We remain with the negative. So negative 1 over 2 factorial is negative 1 over 2. Then we have our h squared. Are you seeing what is happening? Now, are we together? Are we together? Good. You move to the next one. F triple prime of pi over 4, what did you get? Negative? 0.7. But 0.70 you factorize outside, meaning negative is what goes inside. Are you seeing? Because this 0.70711, it is a common factor for all of them. So what goes inside is this negative only, isn't it? Are you seeing that? So we have negative 1 over 3 factorial, which is negative 1 over 6, then it is times h raised to power. Have you seen that? Because you can see here your 0.70 times 1, you get back this, times this, you get back this times that, your negative, you can see it's there, this times that, your negative is for that, isn't it? You factorize out a common factor. Are we together? You factorize out a common factor. So from there, it means we now want to use this to evaluate cos 60. So what is? No, it is not cos 63. We are expanding sine pi over 4 plus h, meaning we are evaluating sine 63 degrees. Are you seeing that? We are evaluating. No, even that cos 63 degrees we can evaluate. I want to show you how it is. It is only that this question was tricky. It needs somebody who understands trigonometry. It is correct. It is not wrong. It is very correct if you are somebody who understands trigonometry. Are we together? So what is cos 63 if you understand trigonometry? My friend, that is not cos 63. We are evaluating a function. What is cos 63? Huh? That is a cofunction identity. It is what we've used here. It is what we were even using to see what is happening here. That is the cofunction identity. Cos 63 is equals to sine 27. Cofunction identity. When the sum of the angles add up to 90 degrees, then the cosine of those are complementary angles. The cofunction identity. You can see 63 plus 27 add up to 90 degrees, isn't it? Meaning sine 30 will be equals to cos 60 because 30 plus 60 is 90 degrees. Complementary angles. Are you seeing? the same sine 60 will also be the same as cos 30. If the sum of the two angles add up to 90 degrees, then the cosine of one angle is equal to the cos of the other angle. Are you seeing? So it means when you are now using a sine expansion to evaluate a cosine angle, then you use the cofunction identity, isn't it? And you can now see very well that cos 63 degrees is the same as sine 27 degrees, meaning it is the sine we can evaluate from this expansion, isn't it? So cos 63, instead of evaluating cos 63, we are evaluating sine 27. Are you getting that? Are you seeing how correct it is? Huh? Very correct, isn't it? Now, this sine 27 must be expressed in this form which is here, isn't it? It must be expressed in the form you have here. Are you seeing this? Which form do you have here? Sine, look at that. You have sine pi over 4 plus h is supposed to be this sine 27 degrees. Are we together? Are we together? Because it is this sine 27 degrees, meaning where sine pi over h is, you are going to put sine 27 degrees, meaning they must be equal, isn't it? So you now start, it must be pi plus h. So look here. So what do we have here? Pi over 4 is what? We have sine 27. Pi over 4 is the same as 45. Serious? So it is 45 minus 1 to give you 27 degrees. It is 45 minus? What is wrong with you? This term here must be pi over 4. Meaning pi over 4 is 45 degrees. Pi is 180 divided by 4, isn't it? 45 degrees, meaning this is not 45 degrees, this. Meaning what is h? For you to get 27 degrees, which you have here, it is 45 minus 18, isn't it? So what is our h? Negative 18? Negative 18 degrees. Are you seeing the value of h? The value of h is what we need, so that when we substitute the value of h here, we found sine 27 degrees. Are you getting the point? Because we already know x. X we've been given is pi over 4, 45 degrees. They are trying to tell us that this is your pi over 4 plus h. This must just be 45 degrees. But we now want to evaluate 27 degrees. 45 minus what to give you 27, because we are comparing, isn't it? Meaning, in 27 degrees, the same as 45 minus 18, because what starts here must be 45, pi over 4, you see? So it means it is x plus h, meaning x is your 45 the way it is here, then your h is now what? Have you seen you found the value of h? Are you seeing what I'm doing? H is negative 18, and you cannot evaluate it in degrees because you can see this value here is pi radians, so h must be pi radians. Are you seeing what I was trying to say? Because when you are going to multiply at 18 degrees squared, and this is pi radian, is that even making sense? That is relevant, meaning that degrees must be converted into pi radians. Have you gotten the point? So from here, you see 45 degrees is already converted for you pi over 4, what you have there, isn't it? Then it is now this h, you now convert. So here we have sine, we now have sine 45 is the same as pi over 4, then you convert 18. So it means this negative 18 is going to form the value of h. Is that okay? Is that okay? So can you convert that? Remember, 180 degrees is pi radians. It is the whole revolution to 360 degrees, which is 2 pi, isn't it? See, the whole revolution to 360 degrees is 2 pi. See, that means 180 degrees is pi. Therefore, negative 18 degrees is what? See, that is what you are doing. If 180 degrees is pi, therefore negative 18 degrees is what? See, it is pi times negative 18 over 180. Have you seen that? What do you get with the value of h? 18 goes with 18, so you get negative 0.1 pi, which is what? Because pi is 3.14 something. Senor? Well, that's the value of pi. Yes. So what do you have? Negative 0.1 times pi. 0.3, 5 decimal places, remember, everything is always 5 decimal places according to this. So it is negative 0.15. Are you seeing that? Have you seen what we've done? We've transformed it. Now look here. We've done the transformation. So when we have say pi over 4 plus h, to be equal to say 27. 27 degrees is the same as 45 minus 18 because this must be 45 pi over 4, isn't it? Are we together? So it means say 27, we found is 45 minus 18, 45 is pi over 4, a negative 18 degrees is that. So this value of h is what we are interested in. Are you seeing? So cos 63 degrees is equal to 27 degrees, and we found our h is equal to what? Negative? Because it is pi over 4 plus h, meaning this negative is part of the h value. Are you seeing? It is pi over 4 plus in bracket negative, meaning the value of h is that negative 0.3. If it was pi over 4 minus h, meaning h was that value without the negative sign, isn't it? Are we together? So it is pi over 4 plus h, meaning this negative is value of h. So h is negative 0.31 416. So it means when you found h, you can now evaluate cos 63. When you are evaluating cos 63, you are evaluating sine 27 degrees, which is equals to what? At sine 27 degrees is the same as this. Meaning, when you substitute it here, where there is h, you put that. Are we together? So the best way to substitute that is to do what? Sine 27 degrees will be what? This is what you do. You go to the calculator, you press negative 0.31416 is equals to what? Are you seeing the procedure I'm following? This value of h, instead of coming and writing the whole of it, you will mess up. Just go to the calculator and press negative 0.31416 is equals to what? So it is equals to the way it is. So it means when it is equals to that, it is the answer. It is now the answer, isn't it? So when it is now the answer, you now go to the calculator, 0.7011. You don't press an on button, you will reset the answer. You only press an AC, or you don't press anything at all, isn't it? Are we together? So here we have 0.7011 in bracket 1 plus answer minus a half answer squared minus 1 over 6 answer cubed. Because the value of h is already the answer in the calculator. Are you seeing that? Are you seeing what I've done? Yes. The value of h is already the answer in your calculator because you press negative 0.31416 is equals to, when the moment you press equals sign, it displays it, h is now answer, isn't it? So when you are substituting, you have 0.701711 in bracket 1 plus answer minus half answer squared minus 1 over 6 answer cubed. Because your answer is this. Is that okay? So what do you get with the answer? What do you get with the answer? When it is time for you to use calculator, you use calculator. What have you found? 1? You found 0.45? 37, 5 decimal places. 5 decimal places. 0.45372. Remember, once you press that formula, you can reconfirm. You can reconfirm by pressing the value of h again. Once your formula is here, it's in the calculator. Which one has a formula? Yes, this one. So once you have your formula like this in the calculator, what you do, you can press the value of h again, negative 0.331416 is equals to what? Then you replay with the upper button, isn't it? You replay to get back, until you get back your formula there. Then you press equals to again. You see? To reconfirm. See there? Good. So this is the value of cos 63. So can you confirm cos 63 when it is approximately something close to this? Because this is approximated value, isn't it? It is approximated with up to h to power 3. Can you confirm? Remember when you are pressing cos 63, you take back your calculator to d, isn't it? For degrees, isn't it? See, your calculator is in R. Yes. So can you take back your calculator to d for degrees to give us cos 63? What do you have? 0.453 something, meaning it is approximately this, isn't it? Yes. Then you are very right. Are we together? Good.